Hey guys, I'm Adriana,
And I'm Keon.
and today we're going to teach you about Chapter 9, Lesson 1, Ellipses. What is an ellipse? Well, an ellipse is a curve on a plane determined by a set of points such as the vertices and foci. The vertices are the endpoints of the major and minor axes of the ellipse, which you can see right here. Both axes, x and y axis, hold vertices, and really, when you're graphing an ellipse, the vertices are included in that. You can see sort of distance from the vertex are foci, and foci are two points plotted along the major axis, which help shape, almost predetermine the shape of the ellipse. The major axis, which is right here, is the predominant axis that's graphed in between the major vertices. So let's say you have x, the vertice for x is 2, and the vertice for y is 1. The major axis would be 2 because 2 is clearly greater than 1. The minor axis would be 1, y equals 1, which is the minor axis, and that you can see here. The minor axis is a smaller axis that's graphed in between the minor vertices.
The standard form of an ellipse is the algebraic expression created to help graph the ellipse using the vertices and the origin. The standard form only works for ellipses centered at the origin. This is because x and y are points at the origin. A and B are our x and y axes vertices. A will represent our x-axis vertices, and B will represent our y-axis vertices.
Now, the main difference between a centered ellipse and a non-centered ellipse is where the origin is placed. With non-centered ellipse, they use a different format in order to graph it. Here, the format you can see is x plus or minus 8 squared over a squared, which represents the x-axis as well as the x point of the new origin point, plus y plus or minus k squared over b squared, which is again the y-axis plus the newfound y position of the center point equals 1. It's similar to the standard form, but it's different because, as you can see, h and k represent translations from the original point xy, which is previously 0, to the new point, which may be, if h is minus 2 and k is minus 1, the new point would be 2 and 1, respectively.
In order to find the foci, you need to analyze and use the A and B vertices in the equation. The variable c represents the foci in this equation. We see it pictured here, 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 and here. C squared equals a squared minus b squared will be used when a is greater than b. C squared equals b squared minus a squared will be used when b is greater than a. For example, if you have a is equal to 2 and b is equal to 3, then your equation would be c squared equals b squared minus a squared, or c squared is equal to 3 squared minus 2 squared. So our first practice problem is 25x squared plus 16y squared equals 400. So we're going to write this down, and we're going to divide both sides by 400. And then we're going to simplify, which is going to get us x squared over 16 plus y squared over 25 is equal to 1. To get it into standard form, we need to have a and b squared. That would be 16 and 25. We need to square them. So that would result in x squared over 4 squared plus y squared over 5 squared is equal to 1. That would make our vertex 4, 5. So 4, 5.
Okay, so with the finale problem, we're going to solve a word problem created by us to test our skills with ellipses. Anakin loves the beach. He goes every weekend and loves to surf the waves, though he hates the sand. One day, Anakin sees a great wave along the coast and decides to surf it. The elliptical-shaped wave stands 10 feet tall and 20 feet wide. His surfboard is 2 feet wide, and he's 6 feet tall. Will he be able to make it through the wave without any collisions? Find the height of the archway, including the width of his 2-foot surfboard. Hint: Anakin's height shouldn't be taken into serious consideration. It's just a matter of fact. On the next slide, we'll be going over 3 simple steps on how to solve this problem without any mistakes and errors. Step 1, we're going to plug in the known vertices into standard form. So we know that a wave is 20 feet wide, which really equals 10 feet wide on each side of the graph. So that will be written as 12 x squared over 10 squared plus y squared over 10 squared. Y squared over 10 squared? Well, because we know the wave stands at 10 feet tall. So if we know the width and the length of the wave, which could be plugged in for A and B because those are the vertices, equals 1, because we're trying to solve for standard form. And if you want to solve this completely, it'd be over 100 plus y squared over 100 equals 1. Next, we're going to plug in 2 into x, where previously it was the origin point, because that is technically the origin point for the width. And again, we're going to put this in standard form. So 2, and where x was previously, will be 2 squared plus y squared, which is the height which we need to solve for, equals 1. Now, what do? Simply, all we have to do is solve for y squared, because that stands for the height of the wave from the bottom to the bottom of the surfboard, which is 2 feet wide. We're going to multiply 100 to both sides, which will give us 4 plus y squared equals 1. So now we have the equation 4 plus y squared equals 1. So now all we do, 100. My bad. I forgot that you need to multiply 100 to 1 as well. So now we have 4 plus y squared equals 100. Subtract 4 from 100, which will leave you with y squared equals 96. This means when we square root both sides, y equals 9.79, which we will estimate to be 9.8. So the distance between the top of the wave to the bottom of the surfboard is 9.8 feet, which is enough for anything to go through. Ellipses. 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 Ellipses.